Okay, today's Chem Catalyst is going to be 36.1, and today's problem is that you have 2.5 liters of gas at an unknown pressure. However, we know that at 1 atm, its volume was measured to be 8 liters. What was the unknown pressure? So what you want to do first is find the variables that you already know and then decide what gas law you want to use. Do you want to use Boyle's, Charles, or Gay-Lussac's? Or you could even use a combination, aka the combined gas law. So I'm going to highlight what we know from the problem. So we know that we have 2.5 liters of gas. Now it's at an unknown pressure, so these two are linked together. So this one's going to be my V1, my unknown pressure is going to be my P1. However, at 1 atm, we know its volume was measured to be at 8 liters. So this is going to be our P2 and our V2. Using your foldable, decide which equation is going to have your pressure and volume. Awesome, it's going to be Boyle's law. So let's set this up. Boyle's law says that P1 V1 equals P2 V2, our initial conditions and our final. We know that our P1 is going to be unknown, so I'm going to put an X here. My V1 is going to be 2.5 liters. My P2 is going to be 1 atm, and my V2 is going to be 8.0 liters. So when I plug it in, I'm going to have my X value here, my 2.50 liters here, equal to my 1 atm here, and my volume 2 right here, 8 liters. To get X by itself, I'm going to divide both sides by 2.5 liters, 2.5 liters. Notice how liter and liter will cancel out, and we're going to be left with our desired pressure unit, atm. So now it's the time to plug it into our calculator. We are going to have basically 1 times 8, 8 on the top, divided by 2.50. And we're going to see that we're going to have 3.2 as our answer. And our unit is going to be the unit that did not cancel out, atm. So our pressure unit, so our answer is going to be 3.2 atm. Now, if we were doing sig figs, we'd look back at our givens. So we see 2.5 has 3 sig figs, 1 atm only has 1, and 8 has 3 sig figs. So if we want to round to sig figs, we would round it to 1 sig fig, and our final answer would be 3 atm. Now, last week we were looking at the named gas laws. We had Boyle's, Charles, Gay-Lussac, and when we combined them, we had the combined gas law. Now, they dealt with P, T, and V, but as chemists, they wanted to connect gases with mass or moles. So they needed to have another equation which had this concept in it. So introducing your own little drum roll, the ideal gas law. So locate the ideal gas law on your foldable right now. Now the ideal gas law is different from our other gas laws. Instead of having initial and final conditions, you'll see that our ideal gas law has just one P, just one V, and just one T. Now we're introducing 2 new letters, our N and our R value. So P still represents pressure. It must be an ATM or kPa. We will not be using torr when we're using the ideal gas law. If it is given in torr, just convert it to ATM or kPa. Volume must be in liters. So that's a key point that we have here. Don't forget that for every 1 liter, it's 1,000 milliliters. Okay, introducing our new variable is our N. Our N represents the number of moles. So make sure that if you're looking for N, you're looking for how many moles. Our new letter also is R. R is a gas constant, so it doesn't change, but it's key to know that for ATM, it's going to be 0.0821, and for kPa it's going to be 8.314. This here is not equations, they are just units. You can choose to write it down on your foldable, but you might find it easier to write that for ATM it's 0.0821, and for kPa it's going to be 8.314. Now T is going to be temperature, and notice that it must be in Kelvin again. So don't forget that it's going to be Kelvin is equal to your degrees Celsius plus 273, which you can also find in your foldable that you have on your desk. So the ideal gas law is going to be PV equals nRT. P for pressure, V for volume, N for moles, R is our gas constant, and T for temperature. So let's do this one together. The first thing we want to do is locate our different variables in the problem. So at 34 degrees Celsius, the pressure inside a nitrogen-filled tennis ball has a volume of 0.148 liters and is at 212 kPa. How many moles of nitrogen are in this tennis ball? So I'm going to highlight that important information, and then we need to decide what variable it is. So 34 degrees Celsius is going to be our T for temperature. We're going to see that it tells us our volume is going to be 0.148. That's going to be our volume, and it's in the right unit, liters. We also see that they tell us the pressure of this tennis ball is 212 kPa, and that's going to represent our pressure. Note that it is in kPa, and that's going to help us decide on what R value we need to use. So how many moles of nitrogen are in this tennis ball? So don't forget that moles is going to be represented by N. So the ideal gas law is PV equals nRT. So let's list out what we already know. So our P, our pressure, is going to be 212 kPa. Our V, volume, is going to be 0.148 liters. Our N, we don't know. That's going to be represented by our X. Our R value is going to be the same for kPa. So if we look back at our foldable and our equation, you'll see that for kPa, we're going to use the 8.314. So our R value is going to be 8.314, and our T value is going to be 34 degrees Celsius. Now don't forget, temperature must be in Kelvin, so we want to add 273 to this. So in our calculators right now, if we're following along, 34 plus 273 is going to be 307 Kelvin. And we'll use this number when we plug it into our equation. So let's set it up. PV equals nRT. Okay, so our P is going to be our 212 kPa, our V is going to be 0.148 liters, our N, we don't know, our R is 8.314, and our temperature is going to be 307 K. Now our R constant, remember it had that very long unit that we see here, and this is going to help us cancel out our kPa, our liters, our Kelvin, leaving us with moles in this equation. So let's solve out for X. We're going to divide each side by 8.314 and 307 to get our X by itself, aka our N value. So let's put 212 times 0.148, and that's my top answer, divided by, open parentheses, 8.314 times 307, close parentheses. And we'll see our answer is quite small, but it is correct. 0.01229. Okay, so we're going to have moles as our unit. We'll go back to our problem. So we're going to have 2 sig figs here 3 sig figs here, and 3 sig figs here. So our lowest number is going to be 2. Now remember, these are not significant, so we're going to start at our 1, 2. Will 2 round 2 up? Nope. So we're going to have 0.012 moles of nitrogen in that tennis ball. On a separate sheet of paper or in the back of your foldable, you're going to try this one on your own. So when the temperature of a hollow sphere containing 685 liters of helium is held at 621 Kelvin, the pressure is 1,890 kPa. How many moles of helium are in this sphere? Now let's take a look at your answer. So hopefully you found out that key pieces, that 685 liters is going to be my volume, 621 Kelvin is going to be my temperature, and 1890 is going to be my pressure. In this problem, yet again, we're looking for moles. So we're going to use the ideal gas law here to solve for N. Now you could also rearrange the equation to solve for N first. If you feel more comfortable plugging in the numbers here, that is totally acceptable. So just as we always do it, let's get our givens down. So we're going to have our P as our 890, V as 685 liters, N, I don't know, so I can call that my X. R value, 8.314. And don't forget that this is just a unit to help cancel out all of these units, making sure to leave mole. And last but not least, our temperature was 621 Kelvin. So we actually didn't have to add 273 to this equation. So when we plug it all in, you're going to see that I use the N one, meaning that I'm going to solve out for my moles. So I'm going to have my P and my V on the top, my R and my K on the bottom. So we're going to use this to cancel out our units. The unit we're left with is our moles, and it's our desired unit. So now let's plug it into our calculator. So open parentheses, 1890 times 685, close parentheses, divided by, open a new parentheses, 8.314 times 621, close parentheses. So we can do that in one fell swoop. Okay, let's hit enter, and we're going to get our answer to be 25075 and a few other numbers after it. So let's go back up to the problem and see how many sig figs we have in each one. So 685, 3, awesome, 621, 3 also, and 1,890. This one at the end is not significant, so we'll also have 3. So let's count over. 1, 2, 3. Will 7 round 0 up? Yes, it will. So we're going to have 251 moles of this helium in this sphere. Okay, so take out your ideal gas law practice. It's going to be page 4 of your gas law classwork homework packet. So you can work in small groups of 2 to 3 people and complete the back page, page number 4, and you're going to complete 1 through 3. Please complete it on a separate sheet of paper so you can show all of your work.